So yeah, so this is the tree problem, which is given in the problem of the day today. And what he will do, initially he will give you two binary trees, and your task is to check their levels are anagrams of each other or not. Now again, what is an anagram? Anagram is nothing but the frequencies of both the strings or anything should be matched. Like if you consider the level, the first level here it will be one, and here it will be one as well. Now if you consider the second level, then it is 2 3, and here also there is 2 3. That means the frequencies of the each levels should be matched. Here the task is to check the each levels are anagrams of each other or not, right? So what we want to do, you want to just check whether these two levels are anagrams or not. So for this what we will do, we will be using the breadth first search, which is nothing but here the level order traversal. Before solving this question, you need to know what is the level order traversal. If you know the level order traversal, then it will be a piece of cake to solve it, right? So let us understand this by taking a test case. So I think it will be better if you watch in 1.5x, right? Okay. So initially I have drawn the two trees that what he has given us. So what we will do, this is our level 1, right? This is our level 1, and this is our level 2, and this is our level 3, right? This is our level 3. Now initially I'm taking a two queues, which is q1 for the tree 1, and I'm taking a q2 for the tree 2, right? Now, what I will do, I'll just push the first level of the tree 1 in the cube 1. That is nothing but 1, right? That is nothing but 1. So, whatever I have pushed in the cube 1, I'll just increment the frequency. I'll just increment the frequency in my map. So, my 1th element contains one frequency, right? Now again, I'll go to tree 2, and I'm gonna push the first level in the Q2. I'm gonna push the first level in the Q2, and whatever I'm pushing that level in the Q2, I'm just decrementing the frequency of those element in my map. Then what is my so finally what is the frequency of my one-th element? That is 0, right? Because it is cancelling with each other. I'm incrementing the count of 1 in the tree 1, in my map. And when I was going to the tree 2, I'm just decrementing the frequency in that level. I'm just decrementing the frequency. So after this level, we'll again move to the level 2, right? We will again move to the level 2, which is nothing but q1 will contain 3 and 2, right? Q1 will contain 3 2, and I'll map their frequencies in my map by incrementing the count of 3 and 2. Now my second level in the tree 2 will contain 2 and 3, right? 2 and 3. Now, what I was doing, whatever the elements that I'm pushing in the Q1, I'm just incrementing the frequency of those elements. And whatever the elements that I was pushing in the Q2, I was just decrementing the count of those elements. I'm just decrementing the count of those elements in my map. Now, if I decrement this count, the 2th frequency will become 0, and the third number frequency will become 0, right? They are cancelling with each other. Now, after a level order traversal of each level, you'll check your map. If it is containing any value with a frequency not equal to 0, then can I say those are not anagrams because they don't cancel with each other. It is containing some element with frequency not equal to 0. It is indicating that they are not anagrams, right? Because their frequencies need to match with each other. Their frequencies need to match with each other. If they are matching, then they should be zero, right? Because I'm incrementing the count in the tree 1, and I'm decrementing the count in the tree 2. Now if you come to the level 3, then what will be our what will be our queues? Then 5 and 4 will be pushed in q1, right? 5 and 4 will be pushed in q1. Now what is the level that is pushed in the q2? That is 6 and 5, right? 6 and 5. Now when I was pushing in the q1, I just increment the count of those elements. Then r5 will have 1 and r4 will have 1. Now, when I was pushing in the Q2, I was just decrementing the count of those elements. Then my 6 will become -1, and my 5 will become 0, and my 5 will become 0. Now, after the level order traversal of this level, once again you'll check the map. Once again you'll check the map. And if it is containing any value that is not equal to 0, then can I say those frequencies are not matching? Those frequencies of the level are not matching, because here 5 4 and 6 5, the 5 has become 0 because it has same frequency in both the trees. The 4 and 6's frequency are not equal to 0 because their frequencies are not matching in both the trees. Their frequencies are not matching in both the trees. So this is the main intuition behind this. You need to just know the level order traversal and the BFS technique, and and you can solve this simply by hashing. Now let us move into the solution. Like, see what I was doing. Initially, I'm taking a two queues. One is for our root 1 and one is for our root 2, right? I was pushing the corresponding roots in the corresponding queues. I was pushing the corresponding roots in the corresponding roots. Now, what I will do, we will be solving until the our queues are not empty, and you'll take a hash map. You'll take a hash map. Now you'll just iterate for the level 1. You'll just iterate for the level 1 in the tree 1. In the tree 1, q1 corresponds to the tree 1 at the level, right? You will increment the count of those data elements in your map. You'll increment the count of those elements in your map for the tree 1, for the tree 1 in that level. Now you'll again take that corresponding level in the q2, and you'll just decrement the q2 elements, and you'll just decrement the frequency of the q2 elements. Then you'll just iterate the map. If any frequency that is not matching with 0, then can I say those levels are not matching with their frequencies? Then you can just simply return false. See, what we will be doing over here is, initially you're pushing q1 uh, q1 into q1. Initially you're pushing 1 into your q1, and you're just incrementing the frequency. Now your map will contain 1. Now you'll again come to q2, and you'll again push this q1 into your q2, and you're decrementing the count of that element, and you decrement the count of that element. Now ultimately, after this two level traversals, can I say their frequencies count should be equal to 0, because you're incrementing the count of these elements in your map when it is tree 1, and you're decrementing the count of those elements when it is coming to the tree 2. Then their frequencies should cancel with each other. Then their frequencies should be canceling with each other if they are containing the same frequency, right? If anything other than 0, then can I say those frequencies are not matching? So what? So the simple in a simple words, what I will do is, you will make a level order traversal for each tree. just make the level order traversal for the tree 1 and increment the count of those elements in your map. And now you just come to the tree 2, and now you again make a level order traversal, and you just decrement the count of those elements in your map. If the levels are containing the same frequencies, then they will be cancelling with each other, and ultimately you will be resulted in zero frequencies of all the elements. Zero frequency of all the elements. If those frequencies of the both the levels are not matching, then you'll contain some element. Then you'll contain other than zero, right? Either it could be -1 or 1 or 2. It could be anything. If the frequencies are matching, then the particular element should have a frequency of zero. So that is the main condition that I was checking over here. I think it will be simply solved in big of n. It won't take even big of n log n, right? So I'll just quickly submit this. I'll just quickly submit this. You see, it's working. It's working fine.